Question 8 is about vehicle testing and testing the brakes. It gives us lots of information in the question and asks us to plot a speed-time graph using all the information given. So for a speed-time graph we must first of all label our axes. We're going to label them speed, meters per second on the y-axis, and time in seconds on the x-axis. We have to choose a sensible scale for our graph. Now I've got plenty of squares on the bottom. I've added up the total time. 12.5 plus 3.5 plus 5 seconds gives me 21 seconds. So I've got to get 21 seconds in across the x-axis. So I've chosen a scale of 2 seconds for each full square. Similarly, on the speed axis, on the y-axis, I know that my maximum speed is 26 meters per second. So I've chosen a sensible scale going up in 5 meters per second for every full square. What I've done is ensured that I've got over half of the graph paper used in both the x and the y directions. Now I've got to plot the information, and my first part goes up to 12.5 seconds and reaches a speed of 26 meters per second. So my line should represent this. There you can see it. It then says the speed is maintained for 3.5 seconds. So I need to go from 12.5, add 3.5 takes me up to 16 seconds at a constant velocity of 26 meters per second. The final part of my graph, it says the vehicle stops after braking for 5 seconds. So 16 plus 5 takes me up to 21 seconds, and it stops at the end of this. So I'm going to go all the way down to 0 meters per second and intersecting the x-axis at 21 seconds. So the 3 marks come from labeling the axes correctly, speed in meters per second, time in seconds. The second mark is for choosing sensible scales on your axes, and the third mark is for plotting the line as you can see in my graph. Part B is to calculate the minimum length of the track required to carry out the test. Now to do that we have to work out the total distance travelled by the vehicle during the test. Looking at the graph, we can see that the graph is split into 3 distinct parts. The first part, the accelerating, the second part, the constant speed, and the third part, which is the deceleration. Now the area is the distance travelled, so we need to first work out the distance travelled whilst accelerating. That's the area of the first triangle up to the dashed blue line. So area of a triangle is half times the base times the height, which gives the half times 12.5 times 26, 162.5 meters during that first accelerating section. Part 2, the constant speed, is the area of the rectangle. Area of a rectangle is base times height. So we've got 3.5 seconds multiplied by 26 again, giving us 91 meters. The third part is the deceleration, so it's the area of a triangle again, half base times height. So we've got half multiplied by the 5 seconds, again multiplied by 26, gives us 65 meters. And finally, we add those 3 distances together to get the total distance travelled, giving us 318.5 meters. For the marking, you get 1 mark for each of your individual distances calculated, and you get 1 mark for adding together those distances. Now if you made a miscalculation earlier on in the question in one of those 3, you can still get the 4th mark by adding them together correctly. Part C of the question is asking us to calculate the acceleration during the first part of the motion. Acceleration is change in velocity divided by time. So the vehicle goes from 0 meters per second to 26 meters per second. 26 minus 0 is 26. Divided by the time, it took 12.5 seconds to do this. So we have 26 divided by 12.5 equals 2.08, and you must have the units, meters per second squared. So the marks are 1 for the equation, 2 for the calculation and answer, and 3 for using the correct unit. Part D is asking us to calculate the braking force applied to the vehicle. Well, we know that force equals mass times acceleration, but we don't have the acceleration, so we have to calculate the acceleration. And acceleration equals change in velocity divided by time. Now this is for the final part of the graph, and so therefore we take the information from the graph and we can calculate the deceleration of 5.2 meters per second squared. That was 26 divided by 5. So now we can use force equals mass times acceleration. We have the mass from the first part of the question, which is 1,850 kilograms, multiplied by the 5.2 meters per second squared, the acceleration we just calculated, and we get a braking force of 9,620 newtons.